So hi guys, welcome back to our channel after a long time. It has been a tough time through this pandemic year. So stay home and stay safe. Now let's get into our topic, electricity. Electricity is the most important thing in this modern society. Yes, it's a really important thing in this modern society. It is a controllable and convenient form of energy which is used in various places such as schools, hospitals, factories, houses, etc. etc. First of all, what is electricity? Electricity is a phenomenon which has the combination of both static electricity and current electricity. What is static electricity? Static electricity means the charges which are not in motion, which are static and which are stable, are known as static electricity. Then what is current electricity? If the charges are in a motion, it is known as current electricity. Then what is electric current? Electric current means the rate of flow of charge per area cross section is known as electric current. Now let's see about electric circuit. Here you can see a circuit diagram of two pictures. One is circuit picture and another one is a picture of real bulb, a wires and a bulb with some battery. First, here you can see the image of a closed circuit which passes electricity because there is a connection of there is a connection between the electric circuit, so the current passes through it, such as the water flows in a pipe. And in this diagram the switch is open. It is called an open circuit. The before one we saw is known as closed circuit. Here is an open circuit. Here the current is not possible. Here there is no flow of charge as it is open. Now here are two examples of static electricity. Number one, if you rub a comb on your hair and take some pieces of paper and bring the comb near the paper, then the pieces of paper will attract to it. So there are no motion in pieces of paper or comb. When you just bring the comb near the papers, they attract. The another example is lightning. These are the two, lightning means thunder. These are the two examples of static electricity. Now let us see what is a charge. Charge is a physical matter which experiences a particular force in electromagnetic field. There are two types of charges. One is a positive charge and another one is negative charge. So like charges always repel and unlike charges always attract each other. This is the rule for the law of charges. It is represented by letter Q and its SI unit is coulomb, C. So the formula for charge is Q is equal to Ne, where N is number of electron and E is charge on electron. So the charge on electron is 1.6 into 10 power minus 18 coulomb. This is the neutral value and the fixed value of electron. At the starting, we learned about electric current. Let's revise it again here. Electric current. The rate of flow of charge through area of cross section is known as electric current. It is defined by letter I and its SI unit is ampere. So the electric current is measured with a particular device called ammeter. It's ammeter. The formula for electric charge is I is equal to Q by T. We can rewrite this as I is equal to Ne by T. We learned that Ne is number of electrons and E is charge on electron, where T is time. Now let's see an example problem on electric current. A current of 0.5 ampere is taken by a filament of bulb in 10 minutes. Calculate the electric current taken by it. So the formula is I is equal to Q by T. But we need to find Q. So if we transpose Q, we'll get Q is equal to I into T. So where I is 0.5 amperes and time is 10 minutes, which is 600 seconds. So we should calculate it. 0.5 ampere into 600 seconds, we will get 300 coulomb. So there are various examples for this. This is the one example I am giving for you in this video. Now let us see about electric potential and potential difference. What is electric potential? Electric potential is the work done per unit charge in bringing the charge from infinity to that point against electrostatic force. Usually, in a conductor, the electrons flow only where there is an electric pressure at its ends. What is potential difference? Potential difference between any 2 points is amount of work done in moving a unit charge from one point to another is known as potential difference. It is represented by letter V and its units is SI unit is volts. The potential difference between 2 points is measured by a device called voltmeter. Can I ask you a question? Name a device that maintains potential difference between 2 points. That's correct. It's a battery or a cell. A battery or a cell maintains the potential difference between the 2 points in a conductor. The formula of potential difference is V is equal to W by Q, where W is the work done per unit charge and Q is the charge. Now let's see an example. So now find the work done for a 2 coulomb charge of 2 points and a volt of 12 volts. We know that the formula is V is equal to W by Q. Here we need to find W, which is work done. So if we transpose W, we get W is equal to V into Q. So the value of V is 12 and the value of Q is 2. So 12 into 2C is equal to 24 joules, where the SI unit of work done is joules. Now let us learn about Ohm's law and who found it. In 1827, George Simon Ohm found the relationship between the current flowing through a metallic wire and the potential difference. He found that the potential difference across the ends in an electric circuit is directly proportional to the current, and the resistance where R is inversely proportional to the current. Here, where the potential difference is high, the electric current flow is high, and where the resistant R is low, the electric current the flow of electric current is low. Here, for the resistance, the SI unit is ohm. The formula is defined as I is equal to V by R, where I is current, V is potential difference, R is resistance. Suppose if we have to find R, then we will get it as R is equal to V by I. R is equal to V by I. Suppose we have to find V, then we will write it as V is equal to I into R. So these are the three formulas stated to find the values when each of them is not true. Now let's get into the topic, the factors on which a conductor depends. Do you know that? That's correct. The factors on which the conductor depends is that by applying Ohm's law, we came to know that resistance of a conductor depends on its length, area of cross section and nature of material. Precise measurements in the resistance of a uniform metallic conductor is directly proportional to the length and inversely proportional to the area of cross section. Here I am going to ask you a question. When the electricity is flowing through the thin wire and it is also flowing through a thick wire, in which wire does the electricity flow fast? That's correct. The electricity flows fast in the thicker wire, as the force of resistance is low. So resistance is always inversely proportional to the area of cross section. Now through these factors we came to the formula. The formula is R is equal to rho L by A, where rho is known as resistivity and it is constant proportionality of the material of the conductor. Here the SI unit of rho is ohm meter, and the resistivity, where rho means resistivity, the resistivity of metals is very low because they are good conductors of electricity, and the resistors of insulators are high because they are bad conductors of electricity. Now here let's see a problem. So here the question is, a wire made of silver of resistivity 1.6 into 10 power minus 8 ohm meter of length 4 meter and radius 0.25 millimeter. Calculate the resistance of wire. You may think, wire made of silver? Yes, it can be made. But it is not made because the cost of silver is so high. Now let's see how to solve it. Now the formula is R is equal to rho L by A. Here if we can rewrite it as rho into L by pi r square. The area of cross section can be written as pi r square. So if we substitute the values rho 1.6 into 10 power minus 8 and L into 4, how you may think how into 7 came. Down the value of pi is 22 by 7. The by 7 will go up and it is multiplied. Here the value of r square is 0.25 mm. If it is converted into meters, then we will get it as 2.5 into 10 power minus 4 and it is squared now. If we substitute it, we will get R is equal to 44.8 into 10 power minus 8 by 137.5 into 10 power minus 8. If we substitute this value, we will get 44.8 divided by 137.5. If we substitute this value, then we will get R is equal to 0.32 ohm. So the resistance is 0.32 ohm. Now let's get into resistance in a system of resistors. There are two types of resistors. One is series and another one is parallel. Now let's see series. What is it? If the electric circuit is connected end to end, then it is known as series resistors. Suppose, for example, if you take a battery of 5 volts, just the 5 volts of the voltage will flow throughout the circuit. So this 5 volts this is for example. So this series circuit cannot be done for large appliances such as bulbs, heaters, electrical machines, generators, because they produce only just a particular voltage which cannot be sufficient throughout the electric circuit. Now let's see the derivation of formula of series resistor. So by applying Ohm's law, V is equal to I into R. By these processing steps, we can get the formula R suffix S is equal to R1, R2 and R3. R suffix S means R suffix series. You all may have a doubt. The resistance should be more than 3 resistors or 4? That's no problem. You can take 2 resistors, then you can take it as R suffix S is equal to R1 plus R2. Not 1 but 2 resistors or 3 resistors or 4 resistors till infinity. How many resistance you can take, you can add, but not except 1. Now let's see an example problem on series resistors. Suppose we say there is an electric circuit which has resistances 20 ohms, 18 ohms and 16 ohms. Then what is the total resistance? Calculate and tell me. You can pause the video and once calculate and answer it. That's correct. The answer is 54 ohms. Now let's get into parallel resistors. If the resistors are connected in parallel, down each down of another, then it is known as parallel resistors. So as we know that the large electrical appliances cannot be connected in series, they can be connected in parallel because it can vary as much as voltage it can. Now let's derive the formula of parallel resistors. By applying Ohm's law, there are 3 formulas in Ohm's law. Let's apply one formula. I is equal to V by R. Here R is dividend. So we get it as 1 by R suffix P. No, there is 1 by R suffix P is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now this is the formula for parallel resistors. Now let's see an example problem on this. Let us say 3 resistors are connected parallel. So the three resistances are 3 ohms, 6 ohms and 12 ohms. Now find the total resistance. Pause the video and answer the question. That's correct. The answer is 1.7. Approximate answer is 1.7. So let's see how it is. If you take the LCM of 3, 6 and 12, the LCM is 12. Then if we add 4 plus 2 plus 1, then we will get 7 by 12. So here 1 by R suffix P is equal to 7 by 12. If you transpose R suffix P and 12, then we will get R suffix P is equal to 12 by 7. Here if you divide 12 by 7, the answer is 1.71 ohm. This is an approx answer. Now let's see what is heating effect of electric current. We all know that the chemical reaction in the electric cell converts into electrical energy. So where does all of this energy go? Yes, this is used in the rotating of fan blades or rotating the motor, etc. These appliances use electric current with heating effect. What is heating effect of electric current? Let's see with the definition. When the current passes through a particular metallic wire, a particular part is heated up. This is known as electrical energy, or we can say that when the current is passing through a metallic wire, a part of energy is converted into a heat and it is heated up. This is known as heating effect of electric current. Now let's see the formula of heating effect of electric current. Consider current I flowing through a resistance R in a potential difference V. Let the time t be the charge q in the work done. So if the charge and potential difference is done in the particular time, then we will get V into Q by T. Or we can rewrite it as P is equal to VI, where P is power. If we need to find heat, then the formula is H is equal to V into I into T, where H is heating effect. Just calculate the heat, where V is potential difference, I is current and T is time. Now let's see an example problem of heating effect of electric current. Let us say a circuit with potential difference 10 volts, current 5 ampere and a time 2 minutes. Find the heat produced in the circuit. Let's take the formula H is equal to V into I into T. Here time is 2 minutes, which is considered as 120 seconds. So if we calculate this 10 into 5 into 120, then the answer is 6000 joules. The SI unit of heating effect is joules. So here the answer is 6000 joules. Now let's get into the topic power. Power is defined as rate of doing work or rate of consumption of energy. As we learnt in heating effect, the formula P is equal to VI. The P is power. So if we take that here, that formula is here used here as P is equal to V into I, where V is voltage and I is current. Or another formula for power is P is equal to I square or P is equal to V square by R. So the units of power is watt, but the unit watt is very smaller. So for big, much larger unit, we can rewrite it as kilowatt. Kilowatt means 1000 watts. In our home appliances, the power is measured as watt per hour. So if we mix up, we'll get kilowatt hour. So if we substitute 1 kilowatt hour, we'll get 1000 watt into 3600 seconds. If we substitute them, we'll get 3.6 into 10 power 6 joules. We all think that the electrons in the circuit are absorbed by the electric circuit, but that's wrong. We pay the money to the electric board or electric company for allowing the flow of electrons through this electric circuit. For example, the flow of electrons in fan or in a motor or in an engine. Now let's see an example problem. Let's say an electric bulb is connected to a 220 volts generator with a current 0.5 ampere. Now calculate the power. Calculate and answer the question. That's correct. The answer is 110 watt. So let's calculate it now. P is equal to V into I, where V is 220 volts and the current is 0.5 amp. So if the point and the 0 substitute, we will get it as 22 into 5. 22 into 5 is 110 watts. So this is the example problem on power I am giving to you in this video. So guys, this is the video on electricity. Let us all together meet in the next video. Till then, bye bye. But don't forget to like, subscribe my channel and share this video so that others can also learn this knowledge. Thank you.